So dear students, welcome back to Advanced CAD for Application class. So today, in this section, we will learn how to make a simulation of a turbofan. Okay. So just turbofan means this fan rotates about some axis, right? So that axis is nothing but axis of is shaft. So if you don't have shaft, you can just select a line, okay, like this one, and we have to select here. We have to use a revolute joint for this purpose, for rotational purpose. So simulation of rotational motion, we use a revolute joint. Okay. So, and the parts of all the fan and the support or shaft provided in your Kyungsum portal or in Google Classroom, I shared. Okay, you can download those parts. Okay. Kinematics, yeah, here. Where is the fan part? This one. So turbofan, CATIA part, and shaft CATIA parts. Two parts are provided in Google Classroom. Okay, you can download those two parts. Okay, and here we have to load those parts. Okay, first we have to open the DMU kinematics digital mockups and DMU kinematics workbench. So we have to load those parts, right? How to load those parts? Insert those parts. So click on product. So I want to insert the parts in the product and insert and existing component. So if there are many parts, okay, suppose if there are many parts, first open those parts in assembly design. Okay, so bring this open or bring those parts to assembly design and create some constraints and make the shape perfect. Later we use kinematic workbench. Okay, so yeah, open those parts. If we have many parts, open those parts in assembly design first. Okay, and make the assembly design first according to the assembly. Okay, assembly design. So like create coincidence constraint, okay, offset constraint, and all these things. We can make the shape perfect shape. Later we can go to kinematics design workbench. Okay, kinematics design or DMU kinematics. Yeah, so click on the product first. Okay, click on the product. So one more time. So click on the product and insert existing component, because I already made parts. Okay, if you want to make parts, insert new part. If you click new part means we have to make part using part design or generative shape design. Okay, so existing component means I already made parts. Okay, and you can download those parts and click on existing component and where are those parts? Yeah, turbofan. So these two parts, so shaft and turbofan, open both the parts. Okay, so it consists of two parts, shaft part and turbofan. So in order to simulate revolute motion, okay, we have to select a revolute joint. Okay? That is the first joint in the joints creation. Okay, here there are many joints. So first joint is revolute joint. Okay, so revolute joint consists of, yeah, okay. So when we select a first joint, okay, first joint, we have to create a new mechanism. Right now there is no mechanism, right? In applications and all these things, no mechanism. So it will ask, create a new mechanism automatically, because there is no mechanism existed in the applications. Or first you can choose a fixed part, then also it asks create a new mechanism. Okay, so first thing, only one mechanism we have to create at a time. Okay, I mean to simulate a mechanism. Okay, rotational motion mechanism, you can create only one mechanism. Okay, so this rotational motion consists of only one mechanism. So yeah, when we create a revolute joint, when we make a revolute joint, it asks whether to create a new mechanism or not, because nothing is existed right here. Create a new mechanism. So I am renaming that mechanism, any name of your choice. Okay, and here joint name also you can create your own name. So revolute 1, right? Revolute 1. So that revolute 1 consists of, so we have to make both the lines same. Line 1 of the shaft, okay, line 2 is the fan line, okay, fan axis. So make sure that both are same, and plane. So you can select this plane, okay. So this plane, YZ plane of the shaft and YZ plane of the fan, or you can also select, so this plane, okay, this plane and this plane. So you can also, yeah, when we select this plane and this plane, both are at some distance, right? They are not at the same location. So there is some offset between these two planes. You have to click here offset, or null offset also okay. So that makes the shaft move, okay. So here the shaft I used only for creating the axis and plane, okay. So if you don't have shaft also, no problem. You can make a line and a plane. That is enough, okay. Without shaft also, we can make this simulation run, okay. Okay, select the line. Line 1 is either fan central axis or shaft central axis. Okay, so here shaft, it is selecting shaft. And next line 2, you have to select the fan central axis, okay. So fan central axis is this one. So sometimes you cannot select the central axis of the fan, then hide the shaft, okay. I already selected, right? I already selected shaft 1 central axis, so you can hide this one. If you cannot select the central axis, okay, you can hide. Then now you can easily select the central axis of the fan. And again, plane 1 is either the shaft plane or fan flat surface, like here. This is a plane, right? Flat surface. Or also you can choose this axis, okay? This plane, sorry, this plane. You can choose YZ plane, okay? So both the YZ planes are same. I'm choosing here this plane, okay? This plane. Yeah, plane is this one, not edge, okay? Here, plane. It automatically selects the plane because we have to select plane. So just I selected the fan plane. Now I have to select the shaft plane. So shaft plane is hiding now, right? I hide that one, hidden. So show that. So you can select this, okay, this plane. Or you can select this plane also. So if you select this plane and all, you have to specify offset, okay, offset. Not, so null offset means 0 offset, okay. When you click on OK, the shaft moves, okay, matches with that plane. If you do not specify here, offset here, that's okay. Even though the shaft moves, no problem for us, because shaft is just fixed part, okay, here. So the location of shaft is irrelevant, okay. Shaft can be anywhere. So you can click here. Plane 2 is here, okay. So yeah, so one more time here. So revolute joint, we have to create new mechanism. That mechanism name is what is that mechanism name? Any name, TurboFan. Okay, TurboFan mechanism, and we have to select the line 1 of the shaft and line 2 for the fan line. And similarly, plane 1 is for the shaft and plane 2 is for the fan. You can also select YZ planes, okay? YZ planes. So click on OK. Here, null offset is selected, right? So the shaft moves to here, okay? So that's okay, no problem. Or if you don't want to move that shaft, you can specify here offset, okay? So minus 50 millimeter automatically detects, okay? So in this case, when you select offset, the shaft doesn't move, stays there only, okay? So just click on OK. So you can choose your angle driven later, okay? You can choose that angle driven later, not now. So click on OK. Yeah. So revolution joint is finished, right? So here DOF is 1, okay? So that means we cannot simulate that one. So restriction motion. And here to simulate, so yeah, this joint, this revolution joint only consists of one mechanism, like one joint, revolution joint. That is enough to simulate, okay, this motion. Okay. So yeah, fixed part is nothing but this shaft is a fixed part, right? One of the part must be fixed, okay, in order to simulate. So if there is no fixed part means we cannot simulate, right? So there must be some support, right? Otherwise the fan will fall down or something, right? There must be some support. Support is nothing but here shaft, okay? Actually, in real case, shaft rotates. Also, with the shaft, fan rotates, right? But here, so the support is shaft, okay? That is fixed. So fix the part. Yeah. So you can see the fixed part is shaft, or you can see here in constraint, fixed part is this one. So these constraints are, you can specify these constraints in assembly design also, okay? You can specify these constraints in assembly design also. So yeah, this is fixed part and this is a revolute joint, okay? Yes, you can expand the arrows if you want to see the applications. So DMU kinematic simulations consists of applications. In that application, it consists of mechanisms, right? Right now, only one mechanism there, that is turbofan mechanism. Okay, turbofan mechanism. I renamed, okay? So maybe your mechanism name is different, okay? And the turbofan mechanism consists of many joints, okay? Right now, only one joint, okay? Only one joint. So that is revolute joint and also consists of fixed part. So still we cannot simulate this one because we did not specify the angular duration like 0 to 360 degrees or how much angle it has to rotate or minus 362. So 0 to 360 means here like this one. So minus 360 to 0 means in the reverse direction, okay? You can specify that one. Or minus 360 to 360 means it can rotate both the directions, okay? Yes. So specify, where to specify? We can specify that angular duration during defining this revolute joint, or you can also specify later, okay? Later, okay. So angle driven, and here you have to check here and you will get this limits, okay, from which angle to which angle, okay. I want to simulate for complete rotation 0 to 360. So 0 to 360 means positive angle is counterclockwise direction, okay. So this is the axis, right? This is the x-axis. So counterclockwise, that is the positive angle, okay. So negative angle is minus 360 to 0 degrees in the clockwise direction, okay. You can specify. So angle driven. So click on OK. So you will get this message. This mechanism can be simulated. So without this message, you cannot do anything here. So for getting this this message, so DOF should be 0. Okay, DOF should be, one of the part must be fixed. Okay, and we have to specify a joint and joint. Okay, and also we have to specify angle driven or range of the angle driven. So without this one, if you did not check this one, not checked means you cannot simulate. Okay, you do not get that message. You have to check this one. Okay, before simulation. Okay, click on OK. Now we can simulate because I got a message. Mechanism can be simulated. So then, so for simulations, either you can use this one, simulation with commands, and or you can use this one. So simulation with commands means you can specify how many number of revolutions you want. Okay, and also you can specify the angle. What is the angle? Suppose 10 revolutions I want means 3600 degrees, right? So you can specify here, but here I choose here this one. So because if I choose this one, I can save this simulation, but here this is a temporary. Okay, temporary. Okay, here simulation. Yeah, here is consists of steel material and steel material. So I'm not simulating it. Just this is the mechanism, right? I created. This one you have to select. This is not. This is just a material. Okay. So turbofan. Yes, turbofan. Yeah, you should be very careful here. So watch carefully. So first, before, yeah, so this you have to get two windows here. One window is here, this one, and another window, two windows. Okay. If you are not getting two windows means you cannot simulate. Okay. Maybe you forgot to fix some of the parts or you forgot to specify the angle range. Okay. Angle driven checkbox is not selected. So yeah, when you click on this one, you will get two windows. So one is simulation range, okay, 0 to 360 degrees. So first we have to check here whether we can simulate that one or not. Okay, yeah, in that direction. Yes, bring your cursor from here to here, bring this button from here to here and check first. And after checking only, after checking this one only, we insert, okay, insert something to save simulation, right? Insert, okay, and this arrow means only one direction simulation, only one time. Okay, and here when you click again, this arrow means like this one, right? So this means one direction like this one and another time like this one. So one direction forward direction and another direction is reverse direction. You can simulate this one only one time. You can simulate that one. And if you want to continuous simulation, right, continuously, so like many number of revolutions I want to simulate, so I choose rewind option okay, here. So after simulation finished, okay, so continuously, yeah, I choose this arrow, two arrows, okay, rewind button, that is rewind, automatically rewind. Yes, first we have to before insert, so be careful before insert, we have to make sure that this one moves from 0 to 360 degrees, okay, because I specified angle driven, right, 0 to 360 degrees. So move that one and check whether it is rotating or not, then click insert. After that you click this arrow, okay, I mean you can choose one direction or forward and reverse direction or completely forward in many times, okay. And also this one is time step. So time step one is very fast, okay, very fast. So I choose 0.01. Slow, simulate slowly. And also now both the buttons are here, right? Both the buttons are here. So we can click here to simulate in this direction, okay? in this direction. So, but here I want to make this line positive direction, okay, not in reverse direction. I want to click here, this button, but both the buttons are here, right? Both the buttons are here. You have to bring these two buttons here, okay? So this should also be here, okay? So then, yeah, you can click here, jump to start, okay? This one is jump to start, and this one is jump to end, okay? So if both the buttons are at the end, click on the reverse background mode. If both the buttons are in the start mode, okay, start mode here, the starting point here, okay, you can click here, forward mode, okay. So I want to simulate in forward mode only in this direction, okay. So make sure that both the buttons appear here, okay. You can drag or jump to start, okay, and so click on play, yes. Okay, click on play and click on OK. Okay, so that one, suppose here 0.01 is the minimum time step, right? Minimum. So I want to reduce further 0.0001. So yeah, I already make some simulation, right? That is simulation. So if you choose this one, you can see this window. I mean, you can see simulation already saved. But if you choose simulation with commands, it will not save, okay. I'm choosing this one because I want to save this simulation. And once we have this simulation, okay, once we have this simulation, we can reduce the speed, okay, 0.01 to, I want to reduce the speed further, 0.001. If 0.01 is too high speed, okay, 0.001 second. And also once we have this simulation, we can save this simulation, okay, animation and all these things, okay. Yeah, let's reduce the speed, okay, reduce the speed. How to reduce the speed here? Simulation player, okay, simulation player, and here. So what is the simulation? You have to select this one, select this simulation. I want to reduce the simulations 0.01 times. So right now 0.01, right? Here you have to click here, Control Shift P, parameters, change the parameters. So 0.001, okay. Sampling step 0.00, further slow. So 0.0001 means very, very slow, okay. Yes, you have to click here, select this one, simulation player. And so for which simulation, we have to select this one, and yeah, we have to click here and select the step size, 0.001 second, and here, okay, and play that. And yeah, so this one is only one time, this arrow means only one time, so you can rewind, yeah, many times, okay, and play. So slow, very slow, right? So very slow motion. So sometimes 0.01 is very, very fast, okay? You can make further slow by using this one, simulation player, and click on the simulation and change the parameters here and reduce the size. Okay, so that is the end of this one, simulation of turbofan mechanism.